Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. This episode is the first in a two-part series about online partial discharge monitoring, a topic we have covered before in Energy Talks, but a topic that is always good to revisit. PD monitoring is quickly moving from a nice-to-have to an essential condition assessment tool for electrical assets, especially in aging infrastructures. In this episode, I will talk to my guests about the transition many asset managers and maintenance engineers are currently navigating as they move from time-based to condition-based maintenance with the help of continuous online monitoring. We're going to look at the practical drivers behind this shift toward a more informed, data-driven strategy for asset planning. Joining me for this discussion is Daniel Gebhardt, a partial discharge specialist and PD monitoring system product manager at OMICRON. Also joining me is Hendrik Schleifer, who is a PD monitoring software developer and product owner at OMICRON. Together, they will discuss the benefits of using online PD monitoring to effectively assess the installation condition of electrical assets, especially when and where to use temporary or permanent PD monitoring solutions, and how it results in greater peace of mind. Daniel and Hendrik, welcome to Energy Talks, and thank you for joining me for this episode.
Hi, Scott. Thanks for having us.
Hi, Scott.
In this episode, we are revisiting a topic that has been presented before on Energy Talks, and that is the vital role continuous monitoring has in making the move from time-based towards condition-based assessments and maintenance of electrical assets. So, based on your experience in conversations with those responsible for ensuring the reliability of electrical assets, what have you understood to be the stress factors that would lead them to consider implementing a continuous monitoring system?
Asset managers, the same as maintenance managers, have to take care about a lot of different topics around their assets. So what they really don't want to have is something unplanned. They are planning a lot of tasks, and as soon as you have unforeseen issues hitting you, this gives you unplanned downtime. So what you want to have the best picture available of your asset, so you can plan your maintenance or your interactions accordingly.
If I might add, if you look at the machines in terms of partial discharge and you want to assess the criticality of your defects, this typically requires a lot of specific knowledge about the topic. So you would need access to specially trained people who can assess the PD situation of your machine. And since this might be difficult to acquire at all times, PD monitoring can help you in identifying the developing partial discharge defects in your machine.
Hendrik, you mentioned how PD monitoring can help asset managers and maintenance engineers identify developing defects between offline PD measurements. Daniel, could you please describe the difference between offline PD diagnostic testing versus online PD monitoring to get this best picture of asset condition?
If we do diagnostics, we normally are triggered by something. Either we had an incident or we had some changes, but we are triggered by something. And then we look at the asset in an offline state. Most of our assets are three-phase assets. So the electrical stress on the asset and on the insulation is totally different in an online than in an offline situation, because the offline situation is normally one phase. So yes, offline is very good to have like an in-depth look on a specific phase. If you want to look for something very detailed, maybe to also assess how you can fix it and where you need to fix it. But to get an overall idea about how your asset is, or how the insulation of your asset is actually aging, how it's developing, if there might be something coming up, the stress in the real operating condition is very interesting, because that's what your asset sees 24/7. That's why if we do monitoring, and there it doesn't matter if we do it temporarily, but if we do monitoring, we look at the asset in an online state and the electrical stress it sees all the time.
Hendrik, how do online monitoring systems enable users to get the information they need quickly about asset installation condition without expert opinions?
What I've always liked, there is this analogy between online monitoring and diagnostic PD measurements, where online monitoring is similar to wearing a wristwatch that continuously monitors your heart rate. This is something that typically will not replace a visit to the doctors once in a while, but it gives you a very good indication of your overall status. So I think the online monitoring in terms of PD helps you a lot in continuously looking at individual defects and their development over time. You get a sense of fault deterioration. Let's say, as an example, we look at a rotating machine, and typically a rotating machine will have some partial discharge. The question is if it becomes problematic or not. And what an online monitoring system allows you to do is just continuously observe each individual defect and its deterioration over time. So if after a year nothing has changed, your situation is essentially the same as it was before a year, you could potentially skip a maintenance phase or an offline diagnostic test.
Interesting. And these offline diagnostic tests, if not prompted by a situation, often happen during planned maintenance. So there are these terms time-based versus condition-based maintenance that have been referenced for years. Why is 24/7 monitoring specifically the breakthrough that finally moves the needle on reliability?
As Hendrik just mentioned, if you do a continuous monitoring, you have an all-time idea about your general status of your asset. So that actually gives you the base to decide if the maintenance, the time-based maintenance, which is done annually or every 5 years, is needed at that point, or if you might be able to prolong it. It also gives you the idea if something changes more rapidly than expected. So if you might need to do a maintenance intervention earlier than planned in your time-based schedule. This is only possible if you have the all-time idea about how is your asset, how is your machine behaving, because otherwise you cannot react on changes.
And vice versa, if I might add, and maybe this is a bit of a soft argument, you could just argue that this gives you certain peace of mind aspects if nothing is changing on your machine. And this is what the monitoring system will provide you with. There is no additional stress factor for you that your machine might act up in the near future.
Based on your experience working with asset managers and maintenance engineers, what would you consider to be hidden costs of an unplanned outage beyond just a repair bill?
I mean, especially when talking about rotating machines, we must make clear that normally a machine is not dying on PD. So the outage itself is most probably not unplanned, but you are in an outage and you realize there are defects that have been evolving, which will prolong your outage. So your whole outage plan is like thrown over and you need to replan also everything which comes afterwards. Normally you plan an outage for your whole site and then you stage the different machines or different assets in there. And of course, if one takes longer than expected because of unforeseen issues, then everything shifts. So cost factor is one. You might have additional, let's say, damages in terms of that you are not able to get fully back online as planned. And of course, it might be a reputation issue that if you are not able to fulfill your contractual deliveries, you would have.
Now, when you say we're monitoring individual assets, but in many cases, there are a fleet of assets. So is it possible to monitor one machine and be able to reflect what might be going on in your other machines? Or is it more beneficial to monitor each and every asset in the fleet?
So there is typically not much conclusion that you can do if you just monitor one particular machine and say something about the state of your other machine. Like even if it's of the same build type, you could probably never say that if the one machine has a problem, the other one will as well. That is just not related. There are essentially two options that you can do in this regard. One of them would be install a monitoring system on each critical rotating machine that you're interested in. On the other hand, you could also do temporary monitoring. So that would be the idea that you take a monitoring device and you install it on your machine for a certain amount of time, let's say 1 month. After a while, pick it up, move to the next machine, and then repeat the cycle in whatever interval that you wish. So you could just rotate the device through or just do this once every year and have a comparison analysis between the various points in time when you took a measurement on this very same machine.
If I might add to this, you could say now, well, this is very close to diagnostic measurement. It is on the one hand, But on the other hand, you really do comparable measurements, because for the diagnostic measurement, normally you either have internal people or an external company which comes by, which connects the measurement device, which does the measurement. So you could say every measurement is somehow different. When you do temporary monitoring, then you connect the very same device with the same settings to a pre-installed connection point, so you have a very comparable measurement to the one you did a month ago, a year ago, whatever. You are also able to derive a development, a trend from this measurement to actually assess if something is changing. Deriving a trend from diagnostic measurement is most of the time very hard, as the conditions around just change too much to have it really comparable.
If I might add, there is also the ease of use aspect. So for this comparability and the same settings that you use at each individual measurement, you do not need special training for this. So like the monitoring device will typically just do everything for you. So your task when performing this measurement would be connecting the device and then pressing a button to start the recording for a predefined interval.
Good point. So we've been talking about partial discharge, and of course we've talked about it before on Energy Talks, the importance of partial discharge or PD measurement, and of course PD monitoring as well. There are so many parameters that asset operators can refer to that will tell them about the condition of their machine, electrical parameters, mechanical parameters. But of all the things we've chosen, we're focusing on partial discharge for monitoring. It's often referred to as a smoke detector of electrical assets. Why do you consider partial discharge to be more effective than just monitoring temperature or oil chemistry?
I would say there are two things to it. One, of course, is the alone aspect. Nobody of us would go to the doctor and just want to know how good or how long he will live by getting his blood pressure taken. So nobody in his daily life would rely on a single parameter. And we should do the very same for our assets. So relying on a single parameter to assess the health of an asset is not good. But, and that's the other thing, there are also for a human some parameters which we would monitor, for example, the blood pressure, to just give it an idea how the whole system is behaving. And for this, PD is a very good indicator, as we can measure it very, very sensitively. We can measure single impulses, so single discharges at any place in the asset. While, for example, a lot of other measurements, you mentioned DGA in oil-filled assets, they are kind of integral. Yeah, I always only get an integral view of my parameter as it changes in the whole asset. So all of these parameters, even if they are monitorable, so if you can get them online, normally don't get you an idea about changes as they happen. So that's like the comparison to a smoke detector. Yeah, that should also go off as soon as there is smoke and not when the room is like filled and it comes out of the windows.
Good point. So going back to partial discharge in the area of online continuous monitoring, whether permanent or temporary, what does partial discharge focus on?
Maybe we take that step back to explain briefly what partial discharges are. Like all our high voltage or also medium voltage assets need some insulation between the voltage and ground. And this insulation system is stressed by the electrical field. As long as everything is within its normal parameters, nothing will happen. But as soon as you start to locally overstress that insulation, you will have small discharges. This is actually something which you can hear when you are under an overhead line in like rainy conditions. You will hear this bristling sound. Yeah? These are also small partial discharges. Yeah, they partially bridge the insulation which is between the conductor and ground. And these partial discharges, which also happened in like gas, solid, and fluid insulation, we want to detect them and we want to be able to alert before they develop into a full breakdown. So before we have the flashover. That's why looking at the partial discharges gives you an essential insight in the insulation system of your asset and in possible defects developing in this insulation system, which is, well, crucial for the asset's life.
Going back to the electrical insulation, why is that such an important component for the condition of the asset?
All of our assets are designed to generate or transmit electrical energy. And to transmit or to have that energy generated and transmitted, we need to have a certain voltage level, as this is driving a current. And this voltage level, we need to insulate the part which is on potential, which is having that voltage, to the surrounding, to ground. And if this insulation fails, well, you get a short circuit. Everybody knows a short circuit will lead to the lights going off, and it won't work. And what is keeping up this insulation? Well, that's our insulation material. So as soon as our insulation fails, the asset will not work anymore as designed.
So we've talked about temporary PD monitoring and permanent PD monitoring. Let's say an asset manager has a limited budget. How do they decide which assets get permanent monitoring versus temporary monitoring?
If you have a limited budget, of course, you would look at the most critical assets first, the ones where you really want to be able to react fast. And these ones should get a permanent monitoring. So everything which is around, which is, of course, critical for operation, otherwise you wouldn't have them, but where you might have a backup, where you have the possibility to live with if it is not available for a certain time, so which are not that highly critical, there you would add sensors and you would set them up to be able to do a temporary measurement at every point in time, so independent of your operation condition. And then you could go with a temporary monitoring on these assets. The nice thing is most of the installations have the connection point which can also be used to connect the permanent monitoring once you decide for it. So it's not an either or, it's more the temporary monitoring is the first step. And if you see the advantage and if you feel the need, then you can upgrade that to a permanent 24/7 monitoring.
Okay, and you're connecting both to permanently installed PD sensors.
Exactly. That's the thing you definitely need to do. You need to permanently install a sensor, as this is like the eyes into your asset to measure the PD.
Okay, so we've covered why online PD monitoring matters to evaluate developing insulation defects in your assets. But identifying the need for a system is just the first step. In our upcoming Part 2 episode, we're going to look at the actual implementation, specifically how to handle partial discharge data without having to be an expert and to minimize noise or false alarms. So be sure to join us for Part 2 as we get into the technical side of using PD monitoring systems. Daniel and Hendrik, thank you very much for joining me for our discussion in Part 1, and I look forward to speaking with you again in Part 2.
Thank you very much.
Thanks for having us, Scott.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.